Welcome, everybody. Welcome to this breakout talk in the Docker technology series. It's going to be about cloud-native developer applications for Docker applications. As you can see, I just read out the title. I'll let Gareth, who's presenting, explain in detail what he's going to be talking about. There are many things he's going to be talking about. Gareth is a product manager at Docker. I think of him as also a visionary at Docker in the application space, so ask away questions-wise. Gareth, I was going to say works out of our Cambridge office, but he doesn't quite work out of the Cambridge office. He occasionally pops into the Cambridge office. He lives in Cambridge, works globally. I think he travels a lot, and is probably out of Cambridge most of the time. He is also the one-man show that's the DevOps Weekly, which I think goes out every week and has been for the last 7 years. So I'm sure there's more to ask on that front. What else is interesting? I tried anybody from England. I keep asking if they watch cricket or have any interest in cricket. The hit rate has been really bad. I don't think, for a country that invented the game, I don't find too many people watching cricket, and Gareth doesn't either. So nothing to add on that one. So with that, let Gareth take it away.
Thank you. Thanks for coming. Hopefully my voice will stay up. I've been speaking a lot, as you've probably seen. OK, so what I'm going to try and cover is really starting off pretty meta, starting off quite high level, talking about the building blocks of applications. And I'll go reasonably quickly because I think it's probably you're familiar with this. This is what a lot of you do every day, whether you're people who've been using Docker for years or people who are just getting started. You'll recognize a lot of the parts, but it's useful context to what I want to talk about next, which is the concept of workflow. Ultimately, how we put those building blocks together. What I would say is that the developer experience has points of friction. As Docker, we want to reduce them. Just going around and saying, how can that be a better user experience for you? How can we make you more productive? How can we make you more agile? And that can be a series of specific problems or more general integration things. So we'll talk about reducing developer friction. I'm going to get along to actually just a lot of demos until I get kicked off the stage. Hopefully all of them will work, but we'll see how we go. I don't have any grapes. That's a bad sign. Yeah, I could drink the bottle of wine. That would work as well. So what are the building blocks for application development with Docker? A lot of that starts maybe a little bit earlier with, you need some computer. I can see lots of you have computers, so we're good there. Hopefully the first application you install on your computer when you get it shiny out of the box is Docker Desktop. So Docker for Desktop for Mac, for Windows, gives you a Docker environment easily, simply, singularly on your machine. You can be on the train, you can be on a plane, you can be using Docker. That was one of the things that appealed to me starting at Docker. Having been a Docker user, I do unfortunately spend too much time traveling. But having a local Docker environment is really powerful. A little bit ago, we also added the ability to click one checkbox and have a local Kubernetes installation as well. So you've got the Docker API, you've got the Kubernetes API, and all you did was ran an executable and ticked a tick box. It's easy to understand, it's easy to install, and everything's integrated together. So all of the networking feels local. All of the storage is integrated. So you've got Docker, you've got Kubernetes, you've got the APIs, you've got the client tools for dealing with that. I would say the next building block really is, you're going to want an image, and how are you going to get one? In lots of cases, and obviously we saw some interesting alternatives in the keynote, you're going to have a Dockerfile. And all this is doing is describing the steps to build your image. And it turns out you've all been using this a lot. And there are like 1.1 million Docker files publicly on GitHub. obviously, that's the tip of an iceberg. You'll have lots of them, hopefully not just on your local machines. Hopefully they'll be in some sort of source code repository. I can't get access to those ones. I can get access to these and do some analysis, which is always good fun. But that's a lot. And Dockerfile is absolutely the de facto standard, the 99% approach to describing a container image. So hopefully everyone in the room at DockerCon on day 2 is familiar with Dockerfile. Hopefully. So you've created Dockerfile, you've built a Docker image, and you can run that. Where your application is simply just a process analog, it's just a single thing that you're running, well, simply Docker run or kubectl run will just run the application. But you might have multiple services that work together. You might have dependent databases or other sort of aspects of your application. You might have networks. You might have things you want to abstract out in terms of configuration. And this is where you need tools to describe the multi-service application. And this is where tools like Compose that provides a high-level abstraction there with a small number of primitives, and where Kubernetes, if you just want the sort of all-you-can-eat large API surface. As we announced in the keynote today, the Compose controller for Kubernetes, Compose on Kubernetes, is now open source. You can already use this on Docker Desktop. You can use this within Docker Enterprise. And now if you have your own Kubernetes installation, you can install that on there. That means you can choose. You have a choice here. You can say, actually, my application has, like Compose fits. It's a bunch of services that are connected, that are probably talking over HTTP or IP. It's not overly complicated. Compose gives you a really high-level abstraction to deal with that. But you can run that on Kubernetes natively. Or you can take the sort of full sort of fat approach with the Kubernetes configs. Again, like as Docker, well, we literally support both in our commercial products. Like we're part of the wider cloud-native ecosystem. These are both good approaches. You're probably going to be building multi-service applications, having them described in Compose or Kubernetes configurations, or actually the tools built around that API all work on our platform, all work locally with Docker Desktop. I missed the most important bit out, however, which is your code. This is the bit that you need to bring. And this might be simple, it might be complicated, it might be huge, it might be small, it might be written by you, it might be written by your team, your organization, it might be written by a third party. This is the important bit. Ultimately, this is where we want you to spend most of your time. So if we've got a series of building blocks, ultimately that's fine, but how do we use them together? Like what do we mean when I say workflow? So going to the dictionary, as I want to do if people have seen me speak before, the sequence of industrial, administrative, or other processes through which a piece of work passes from initiation to completion. That's a bit verbose, really. But it is what we mean by workflow. It's how you tie those tools together, one after the other, to achieve ultimately what you're probably trying to do, which is serve some customer need. And that might be an internal customer, it might be an external customer. But you want to get some code into some sort of production environment, like safely, quickly, like sanely. So how do we build workflows today in our organization? You've got those building blocks. Like what do you do? Well, one approach is, well, you've got those building blocks and the accompanying sort of tools that interact with them, including tools from Docker at sort of low level, including other tools, and the kubectl being an example. I won't hear from any kube control people. Like, you can just use the low-level tools yourself. You can memorize all the flags. You can just run them from memory. Maybe someone documented the 10 different steps that you need to run things, and you invariably fail at one of them because that's a lot of typing and no one can remember them. And ultimately, this way tends to lead to subtle and then invariably not subtle variations in individual workflow. And the issue then comes when there's a cost of collaborating, and that might be within a team, across teams. This isn't about these tools being the wrong thing. It's about them being often at a low level. Sometimes you need low-level tools. But if you can choose higher-level ones, you can probably have a saner workflow. I guess from there, you typically go like, memorizing these things and writing down 100 steps in a runbook is a terrible idea. We should somehow automate this. And maybe you go with shell scripts, maybe you go with make, maybe you go with some other build system. You should go with make. I like make. The team I work with in Paris might disagree with me there, but I'm going to have that argument with them. And here you can say, instead of writing it down, let's turn it into some code. You might you're introducing a new tool at the top level, but that can then provide a user interface that's custom to you, to your organization, to your team, to you and your colleagues. And you've got a single place to reason about that workflow. Like those low-level tools are still probably in use, but you've built actually something that is easier to share. Another approach is actually, rather than to sort of build it yourself, like sort of make sort of based or other build tool based sort of workflows, you might actually say, someone else has made all these decisions for me. And you say, oh, well, actually, we all use an IDE. And actually, that comes with a workflow. It comes with a specific way of doing things. No longer is there the same, well, yeah, we're pick and mixing tooling. We're building our own thing. We're taking the opinions that this specific IDE has. Now, the reality there is actually most IDEs are not actually super, super opinionated. Because people are different, organizations are different, teams are different languages and frameworks and software is different. And you often customize them via plugins. And I guess at that point you can say, well, there's that balance between everyone using the same set of plugins and that are workflow oriented, and everyone being forced to develop in exactly the same way, irrespective of how their personal preferences work. But you can reason about that. Like which of those plugins are really about workflow and which ones are about individual productivity. One of the things about any of those different approaches, and it's not about one being right or wrong, and they're not necessarily all of the options you might go for. There's sort of a balance between several of them. They all have the same fundamentals. Ultimately, when you're building an application, you're going to write some code, you're going to test some code, you're going to build some artifacts, and you're going to run some code. And that's obvious, but it's worth stating. And partly then, because we have a language, we have a discrete number of things that we can talk about and say, well, actually, which one of these is my most painful point at the moment? Where do I spend most of my unproductive time? Or where do we deal with most problems when it comes to collaboration and communication? Because it's only when you're doing that actually talking about tooling makes any sense. If a new tool comes out and it looks shiny and you add it to your way of working, and actually you're just adding something that costs you something, every tool you add costs something. If you're actually optimizing the bit of that sort of process, which is already the bit that's the cheapest, that might not be the best thing to be researching and investigating and adding new tools in. All of the things so far are relevant actually as the individual, but most software is developed in teams, in groups. And that introduces all sorts of, I guess, new parts to that workflow and tooling that accompanies them. Because fundamentally, you need to share. And the sort of source control as a system has been around, again, a little while. but keeps getting better. And I'd say and there are still organizations and people not using sort of modern source control systems. This is, I think, especially when it comes to building modern applications, this is the sort of thing where optimizing for a brand new tool that hit the internet last week versus get good at source control. It's a fundamental part of a modern developer workflow. As is continuous integration. Ensuring you always have a working, integrated version of your software, again, is a fundamental practice of modern software development. Getting good at this is where, this is the thing you invest in before you get good at everything else, I would argue at the moment. And you also want somewhere not just to store your source code, but you want somewhere to store and share and collaborate around your artifacts. And in a Docker world, that would be a Docker registry. Again, we have these very well-defined images, standardized in OCI, all of that coming from the work that Docker's done over a number of years. And the registry being really, again, the registry API is now implemented all over the place. We can store these things and share them inside your network, outside your network, on Docker Hub, on Docker Trust Registry, or others. You don't need to just have the source code. But we didn't change any of the fundamentals, like adding the team. I think communication is an interesting area, but it's not the same sort of level of things. You're still writing code, you're still testing code, you're still building artifacts, and you're executing and running that code. So where does friction come into this? Friction is the resistance that one surface or object encounters when moving over another. Tends to result in conflict or animosity caused by a clash of wills, temperament, or opinions. That was not written about developers, but it could have equally been, I feel. Developer friction is really what I would say, it's the resistance that developers encounter when trying to do your job. Your tools are slow. The network is slow. I want to use that would solve my immediate problem, but it's only available with this language or this framework or this tool. I have to make trade-off choices versus things being more composable. How can we reduce that friction? Because again, coming back to just the analogy of friction, the energy loss to friction is turned to sound and heat. And again, that sounds like an inefficient development team, which is a hot and bothered people and noisy. So how can we reduce this sort of made-up concept? How can we make it easier, faster, better, more pleasurable to develop software? You're all, I think, presumably familiar with Docker, with the basic parts. And you've seen a number of demos today, hopefully, and yesterday on the keynote stage. So I'm not going to recap all of those. I'm mainly going to talk about some things that are a bit more directional. This isn't product announcements as much as areas I find interesting in this sort of taking these discrete problems and how do we, for specific cases, make them easier, more pleasurable, faster, better, cheaper. So, which of these should we start with? One of them I will actually start with is actually one of the ones just recapping from the day one keynote. We announced Docker Assemble. So this will be available for Docker customers. And this is really saying, well, for certain languages, frameworks, yes, you can always write a Dockerfile. Dockerfile is a fantastic general purpose solution. But actually, if you're writing in Java and you're using Spring Boot and Maven, or if you're writing in C# or F# and you're using .NET Core 2, a lot of the information is already inside your ecosystem. It's inside your tools already. You're already providing it. Why provide it twice? You don't often need, and again, sometimes you do, and Dockerfile becomes a fantastic escape hatch at that point. But where you don't need to provide any configuration up front, where you And that's sort of, well, maybe you can go like, well, but it's 10 lines, and I can copy and paste it from the internet. And that's fast and cheap, sure. But you need to maintain that over time. So now you've got 10 of them, and they're all the same, which is annoying. And then one of them drifts a bit, and then there's some variation there and there and there. And now someone comes up with a better approach, and no one knows where all the same Docker files are. And then you end up installing a fancy search engine for your source control, and you've got so far away from your problem that maybe not writing code in the first place was the simplest, best possible answer. So Docker assemble, and just really recapping from the keynote day one, is, again, like, I've provided no configuration. I've not said anything about what's there. I've just run it in the context of a Spring Boot application. And obviously that was cached, because otherwise we'd be pulling down the internet with Maven. But there we've gone from, again, like zero configuration. Zero config is faster to do. There's nothing to maintain or manage. It's also consistent across, like now all you need to do is upgrade the version of the tool, and all your images pick up whatever advantages there are there. And recapping there as well, I was sort of, because it's one of my favorite bits. Oh. There we go. Yeah, and when we control the whole build process, there are things we can do that are harder in the context of just a more general purpose solution like Docker build. And all I'm doing here is inspecting the labels. Inspecting the image and grabbing the labels using JQ. So there are sort of 2 points of friction there. One is actually, there's the friction of like writing a Dockerfile up front. That's not really the barrier to entry we're interested in here. It's the management and maintenance of that across all of the services you're building that's more interesting. But there's also, this contains data on all of the packages and all of the Java dependencies that went into the build. These are the types of things that actually, when that application's running in production and you have a problem, having this to hand, literally attached to the image that's running in production, you trust the tool, this can't be wrong. That's faster. The friction there is to go and find the source code that went into that. What version of the source code was actually in there? Yes, I can go back via you end up in sort of this jumping through your CI system, jumping into your version control system, linking these like that with your production deployment system. And yes, you can automate that. But actually, if we just send all of this to the one system, you don't even have to jump between different systems. So there's sort of 2 examples there of a highly opinionated tool, not intended for everything. It's not intended for every language or framework. Like where we can introduce opinions, often we can target not general solutions, but actually specific ones to specific problems. And this is probably a pattern that, as Docker, we have really good general purpose tools. Where both as a company, but as a community, can we find specific use cases where we can actually raise the bar? Moving on, in this case, to actually a combination of the tooling that we have and third-party tools. Like innovation happens elsewhere, as the famous book goes. One of the tools actually from folks at Google is out there at the moment in the Kubernetes community is Scaffold. So who in the room has come across Scaffold before? Very small number of hands. Excellent. I like demoing things people haven't seen before. So when you're building software, and you're building with Docker, you'll probably write some code. You'll probably build an image. You'll probably run that image. You'll probably look at the result, the output, and cycle. There might be, and you might rely on the sort of unit tests at certain things, depending on the type of thing you're doing. If it's a browser-based application, you're probably looking at spending a bunch of time, again, like writing code, like maybe compiling or maybe not, building an image that often sort of compressed down, looking at the results cycle. How can we make that tighter? Again, sometimes you'll see that integrated into IDEs, but why can't that be available everywhere? Scaffold and a number of other tools in this space are sort of actually targeting that in a developer loop for developers. I say I'm demoing Scaffold because I've only got so much time, but actually have a look at both Draft, at Tilt from the Windmill folks, and Garden. A number of these are super new. They're all really interesting, sort of just in a loop development tools for like this problem. So I'll show you how this works. So here I have a Scaffold config file. Note that this isn't an object I'm going to send to Kubernetes, though the structure looks similar. Some of this is really just boilerplate, but I'm enabling the new build kit builder in the latest 1809 engine with that use build kit variable. I'm saying, well, actually, the image I'm interested in is called Gareth R/scaffold example. And I'm going to deploy to Kubernetes with this manifest, stack.yaml. They're the important bits there. So if we've started there, let's have a look at the stack.yaml file. So this is actually a compose stack, but actually just as a raw YAML Kubernetes document. You could use a compose file. Compose can translate down to this. This can be used directly with the Kubernetes API. That's how the newly open sourced compose controller works. The stack object exists in the Kubernetes API. It's native. We can ask it questions. So the other thing to note here is, well, I have that image that I referenced previously. My application here is actually just it's a very simple hello world Go application that runs a web server, and I have a Dockerfile as well. That uses the MultiStage build bits, which I'll go crazy with in a moment, to build the binary and then push it into a nice small image. Now, I could edit the source code, run Docker build, run Docker run, have a look at the web page, and do that again. But instead, I'm going to run scaffold dev. So, well, it started out, and that's the build output that we're used to from the new build kit enabled Docker engine. And it built an image. Obviously, it was cached. It went nice and quickly. And there's a few bits at the bottom as well. So it's saying stack compose.docker.com hello, which was the name of that stack. It's configured. It completed in 500 milliseconds, and it's watching for changes every 1 second. It should also have brought 5, 6, 7, 8, I think. Is that right? No, I think that's the wrong port now. Is that not worked? Maybe that's not come up yet. Come on. Oh, maybe that's not going to work. Let's do this anyway. So what we can do is modify our application. Hopefully this bit works. Come on. Yeah. So what Scaffold's done is it's noticed a change, and it's rebuilding that application. Again, like Docker build does a good job of caching the right bits. It realized the Go had changed, and it's up and running. So we've got that in a loop. What that's doing is it's noticing changes to either the configuration. So I could change the stack document, and it would do the same. I could change the Dockerfile, and it would notice and rebuild that. I change my source code, and it rebuilds that and redeploys it. So we've got a nice tight developer. Like, it's doing the work I would do manually, often many times a day. Again, there are a number of different tools there. I'd love to hear from anyone using any of them in anger. So Garden, Tilt, Draft, or Scaffold. They're sort of interesting areas. So I mentioned a moment ago the sort of multi-stage builds. Another show of hands. Who's using multi-stage builds at the moment for anything? It's a good sort of like 20, 30% of people. So what multi-stage builds introduced into Docker, and this has been in Docker for a little while now, but there's a number of improvements in the latest engine. Multi-stage builds feature, like, allow you to have really sort of separate stages within the same Dockerfile. So rather than just a series of commands that you run and then it ends with an image, now we can actually have multiple from statements. So you've got multiple from statements, and this is often used, like the previous example, to in sort of compile languages. You have one stage that has the build toolchain, but you don't want to have the final image with that in because it ends up too big, so you copy the artifact across, and the final one just has the compiled artifact and a smaller, faster, more secure image results. Actually, you can do all sorts of crazy stuff with multi-stage builds. And if anyone is doing vaguely crazy things, let me know. I'm collecting patterns, because I think this is an area of rich for experimentation. So I did a whole talk on this, so I'm not going through all the examples. But this is a Python application. I build a base image. I add my source code in a separate image. I've got a test base. I've got this one runs the unit tests. This one runs a series of security checks. I've got this convention going on with lowercase ones being, they're intermediaries. They're things that actually get used as the base for something else. And capital ones are things you might choose to run. So I've got lots of stages in here doing all sorts of different things. But what that gives me is actually a lot of interesting choices and power. Because I've moved a lot of things that might otherwise be in random shell scripts and other areas into my Dockerfile. I said I like make, so I've got a make file to remind me of all my bits. So some of the Docker, internally people have been dogfooding this for a while and have done some interesting things. Yeah, it's a good point. This is just running Docker build. Target is the way you target those stages. So here I've targeted the test stage. And that's actually run the unit tests. I could also, again, the make bit is not required. I could just be running the Docker build commands. Running Docker build target shell. In this case, that's actually benefited from all the same cache bits as the test thing. But then it's dropped me straight into, in this case, a Python shell in the context of my application. Now, what else? Let's do check as well. Oh, that's not vulnerable. That's not interesting. What else could we do? What else is in there? Yeah. And I could have run the application, as in built an image for dev. There's an environment variable set in there that will mean it runs a development version of the web server. Or in the prod one, it actually uses a production web server. So lots of different options. Now, I have a make file, and I did write it by hand, I will admit. But I could auto-generate this make file from the Dockerfile. I could auto-generate other tools to give me a user interface to running my tests, to running my application, to jumping into a shell automatically from a Dockerfile. I think that's sort of interesting. Well, we can auto-generate other things from that file as well. Who's been lucky enough to have a play with GitHub Actions yet? It really hasn't gone out very far. So GitHub Actions is really cool, announced pretty recently by GitHub. Now, again, I did write this by hand, but this could be automatically generated from a multi-stage build. If you look in here, all of the actions are not doing anything clever. They're all just building the targets. They're doing exactly the same thing I was just doing with my makefile, the exact same thing I could have done by hand. Check is the name of that stage. Well, that's all I need. Oh, look, there's a check stage. There's now a check action that runs check. There's a test one. There's a security one. There's a linting one. All of those could be automatically generated just from our Dockerfile. Oh, the application came up as well. Did work. So that gives you actually, in my lucky GitHub account, when I push this application up, well, GitHub Actions automatically runs build, check, lint, security test, runs validate as well. You could do this in any sort of CI system. Again, I could, and I haven't done yet. When I saw the auto-generating like CI code, either like Jenkins configurations, for example, you could do a Jenkins file. You could do, just from your Docker file. Again, we've just killed a load of configuration. We've killed a load of like duplication, and how you run, like how your tests run, is now in the context of Docker identical everywhere. Production, your CI system, locally. So we're killing works on my machine problems as well. And one last demo before I get kicked off. Again, back to being opinionated, and tools not for everyone, but solving specific problems. YAML's all fine and good for various different problems, but I would rather write in a high-level programming language. I really like TypeScript at the moment. It has types. And here is a compose file actually written as TypeScript. Now, within Visual Studio Code, I've got a little setup where me changing this renders the compose file. And I could then I can just use it as if it was a compose file, but I get to write it in TypeScript. And you're like, well, you're weird. Fair enough. What I get out of that, though, is, whoa, hang on, what happened there? There's a red underline. Well, this is not valid. Something's wrong. Well, let's spell correctly, and it should be, oh, that's gone away. Oh, well, they're things I'm allowed to add. I've got type ahead support. I've got inline prompting. I've got inline error checking, like within my IDE. And I have a higher level programming language, so I could share components of compose files across projects just using NPM. Again, I picked TypeScript. You could implement this in your own favorite language. All we've done here is actually generate the interface for TypeScript from the compose schema. This obviously is not a completed integration by any stretch. But again, I think for certain problems and certain people, like this is another area where having that inline help and having a higher level programming language can sort of, without throwing away the simplicity and interoperability of compose files written in YAML, is sort of an interesting area that I'm sort of interested in playing around with. So, coming to closing up. I said I'd pick a number of sort of feels discrete demos. But actually coming back to the things that we've talked about in the building blocks and the workflow, often it's about optimizing single parts of the whole benefits. And the area of build is rich for sort of just optimization. Like if this is your bottleneck, multi-stage builds are really powerful. But also I think there's a load of innovation we can do on top of them. New tools like Docker Assemble can remove the entire need for configuration at all. Like for inner loop development, having something where in some cases you might be doing a lot, or that requires a trade-off choice. You really, really want to use Vim, but actually your IDE does a good job of rebuilding something. Why force that limitation of choice? Let's have composable, shareable, optional tools. And testing. having fast feedback. Some of the things in there, actually, around structure tests and linting that I didn't show all of are generic. They're not about the specifics of the application, while some of them are. How can we auto-generate some of that so you all benefit automatically without having to be crazy like me and set things up and make and GitHub Actions? And I didn't actually go into, but we've spent a bunch of time in the keynotes talking about Docker app and the CNAB work to package up your application. Ultimately, making that shareable as a first-class citizen, again, can reduce the configuration sprawl that you might have for different environments, different teams, different places. Like, it's not just about reducing developer overhead and friction. Like, let's reduce the operator friction as well by defining clear interfaces for them to use. So in summary, I'd always be looking for ways to reduce developer friction, probably specifically in the areas which are most in need of it. Do an end-to-end analysis of where what hurts, and go after find tools in that space first. Improvements might be incremental, or they might actually be revolutionary. They might be doing something fundamentally different, or actually just making that bit a little bit faster. It'll be probably both rather than one or the other. And composable tools are a way that we can do this without saying, hey, you know what? Opt into all of my opinions and it'll be great. Or have a substandard experience, your choice. I don't want to force things on you. Let's have composable tools, because actually, you're all different sensibilities, different contexts. You should be able to choose one of them and tie it together with another one, or eat the whole elephant and buy into all of my crazy opinions about make and TypeScript and various other things. So, closing off, please take the survey. Let us know what you thought about this session, about the conference, about all the other sessions. This report is actually really good, pretty good, about just how we think about Docker in the context of containers and the container industry. I definitely recommend you have a flick through. And if anyone fancies coming to San Francisco at the end of April, we will do all of this again, and it will be even more exciting, I promise. So, thank you. I don't think I've got time for questions.
No time for questions in the general audience, but I'm sure if you're around, people can.
I will be here for a short period of time. I'm then doing a hallway track, as advertised in the keynote, downstairs in the hallway track. I'm sure there'll be more conversations there, and I'll be around for the rest of the day. Or you can find me on Twitter as Gareth R, or on the internet generally. Happy to answer questions there too. Thank you.